Now we're going to be learning how to graph a radical function, specifically square root functions. Now taking a closer look at y equals x squared, if we find the inverse of y equals x squared, which means we invert x and y, so we get x equals y squared, and then we solve for y, we see that y is equal to positive and negative square root of x. So the inverse of f of x equals x squared is plus or minus the square root of x. Now, this plus or minus shows me something very specific in this graph. The plus part is going to be the red part of this graph, and the minus part is the green part of this graph, which means if I just want to specifically look at y equals the square root of x, that's what this part of the graph represents. And if I want to look at y equals negative square root of x, that is this part of the graph. The parent function of a square root function is f of x equals the square root of x. So all the transformations that will occur will start with the parent function. Now, y equals a times the square root of x minus h plus k is the general form for the square root function. A is going to represent a stretch or compression. So anytime that a is bigger than 1, that's going to be a stretch. And if a is between 1 and 0, that's going to be a compression. Now, if there's nothing in front of the radical, that means a is 1, and I have no stretch or compression. Or if we see a negative in front of the radical, remember that means that we have a reflection over the x-axis. Now, h underneath the radical is going to be representing a horizontal shift. So anytime we see minus h, that means h is actually positive and we're going to be shifting to the right. Anytime we see plus h, that means h is actually negative and we're going to be shifting to the left. K on the outside represents the vertical shift. When we see plus k, we're going to be shifting up, and when we see minus k, we're going to be shifting down. So remember, all these transformations start with the parent function. Every square root graph must start with the parent function y equals the square root of x. So let's go ahead and graph the parent function. Now I'm going to pick very specific points for my parent function. These are going to be my go-to points for my square root function. I'm going to pick x equals 0, x equals 1, x equals 4, and x equals 9. Now the reason I pick these points is that they are perfect squares. When I plug in 0, I get 0. When I plug in 1, I get 1. When I plug in 4, well, the square root of 4 is 2. And when I plug in 9, the square root of 9 is 3. So these are going to be my go-to points. So let's go ahead and plot those. So this is what the square root function looks like, and it looks very similar to the green portion of the inverse of y equals x squared. Now when we're talking about domain and range of a square root function, the graph really gives me an idea of what's going on. So remember, domain explains what x values am I allowed to plug into my function. Well, once I'm looking at the graph, this becomes very clear. For x is starting at 0, and then we are proceeding to the right forever and ever and ever. That means that my domain is going to be x greater than or equal to 0. Now my range describes the possible y values that my function achieves. So y here starts at 0 again, and it's going to continue to increase as x increases, which means my range is going to be y greater than or equal to 0. Now this will always be the domain and range anytime I'm dealing with the parent function. Now when I start to shift around, things might change. So here's just a preview of what it's going to look like anytime I have a vertical shift. My parent function here is going to go up anytime I have a plus k on the outside, and is going to move down anytime I have a minus k on the outside. Now keep in mind, by shifting, I'm going to be changing the domain and range a little bit. Now if I'm moving up and down, that means really only the y values are changing, so only my range is going to change. Here's a little preview of what happens whenever we have a horizontal shift. So when we have our parent function here, and then I have a plus h underneath the radical, that actually means h is negative, so I'm going to shift to the left. If I have a minus h, that means h is positive, and I'm shifting to the right. Now here, because I'm shifting left and right, x is changing. That means my domain will change. This function is going to have two different transformations. The negative in front of the radical represents a reflection over the x-axis, which I'm going to do first. And then the minus 1 underneath the radical means I have a horizontal transformation to the right. So the first step is to plot my parent function points. The second step is going to be doing one transformation at a time. So the first thing I'm going to do is do my reflection. So reflecting over the x-axis, this point will not move. This point goes down 1, down 2, down 3. Now I'm going to do my horizontal transformation. So I'm going to shift all these green points to the right 1. Now don't forget to label your axes and to also label your points. Connecting these, this is going to be my square root function. Now domain and range becomes very simple once you have your graph plotted. Now domain, possible x values. So you identify where does your function begin. This one begins right here. And what happens to x? Well, we start here at 1 and we go to the right forever and ever. That means that my domain is going to be x greater than or equal to 1. Now range describes possible y values. So you start at the beginning of your function, and what happens to y? Well, as x increases to the right, y is going to slowly decrease down. So y begins at 0 and decreases down. So that's y less than or equal to 0. Now we can do this algebraically by looking at the function. Remember, underneath the radical, we're not allowed to be negative. So that means x minus 1 has to be bigger than or equal to 0. So x has to be bigger than or equal to 1. Now when I plug in 1 into the function, I'm going to get 0. So I know y starts at 0, but this negative here has to signal to you that you must be decreasing. So y is less than or equal to 0. Go ahead and try this one on your own, and don't forget to list your domain and range.